To pick up where we left off last video, we have this example. In this example, Mr. Stowell has 19 feet of tape to mark an area in the classroom where the students may work on programming robots. Which of these shapes would use the most tape and give the most area for programming? So one thing we want to do is let's just quickly go back and remind ourselves about our equations. If we have a triangle, if we want perimeter, it's just adding up all the sides. Area is half base times height, or base times height divided by 2, either or. Square, the perimeter is just add up all the sides, which is 4 times the side length. Or if we want to find the area, it would be just side times side, which is side squared. Rectangle, length plus width plus length plus width, which is 2 length times plus 2 width. That's perimeter. Area is just length times width. And circumference is the same thing as perimeter. It's just the area, the how far you go around the circle, which is 2 times the radius times pi, or we can think of it as the diameter times pi. And then area is pi times radius squared. So with this example, we have a circle with radius 3. So circle, and we have radius 3. We are looking for which one gives the most area and uses the most tape. So in other words, we are looking for the perimeter or circumference of the object, and also how much space is inside. So this one, we have perimeter, which is going to be the circumference. So circumference of this is going to end up equaling to 2 times pi times our radius, or 2 radius pi. Let's write it that way. 2 times our radius times pi, which would end up being 6 pi. If you want to find the a decimal version of this, all we had to do is just plug this into our calculators, and that is going to be about 18 point, let's do 85, let's do 2 decimals. So that is our circumference. Area, the area inside this is equal to pi times the radius squared, which is 3 squared, which is 9 pi. Find the approximate. So 9 pi is going to end up to give us 28.27 approximately. So that would be our area. Let's compare this if we did a square with side lengths 4. So if you have a square where all sides are 4, perimeter of this, how much tape or how much of the string we're going to use, is just going to be 4 times 4, which is 4 squared, which is going to be 16. So far we can already see that we're using less tape if we use a square than if we use the circle. Let's look at the area. Area, I did my perimeter wrong, is 4 squared, which is 16. Okay, let's fix our perimeter. Perimeter, remember perimeter, we have 4 of these, which again is 4 times 4, which is 4 squared. So we were right on that to begin with. We just wrote it the wrong way because we have 4 of the same sides. So we have our perimeter, we have our area, and notice that perimeter of the square and area of the square, it's not using the most, and it does not give you the most area either. So B would not be the shape that Mr. Stowell would want to use for his programming robots section. Right triangle with each leg being 5. So if you have a right triangle, that means that we have one of the angles being 90 degrees. Let me make sure that I have this as an actual triangle. Make it closed. If both legs are 5, that means that the length beside the right angle is 5, and this other one is 5. Okay. If we want to find perimeter, we need to know this side right here. We need to know what the hypotenuse is. Remember, the longest side of a right triangle is what we call the hypotenuse. Well, if we want to find that, we need to find its distance. Well, to find the distance of a triangle, what we're going to end up having to do is use our distance formula. We talked about distance in a different video. Main idea is that for finding the distance, it is basically using our Pythagorean theorem. If we know the side A squared plus B squared, then we can find the length of C squared, which is our hypotenuse squared. In other words, this would be 5 squared plus 5 squared equals to the hypotenuse squared. So 25 plus 25 equals our hypotenuse squared. which means that 50 is equal to the hypotenuse squared, which means that the hypotenuse, we'll get there, the hypotenuse of this is equal to the square root of 50. That is the length of that longest side. So perimeter is really just 5 plus 5 plus square root of 50. Adding those together, this would end up to give us a grand total of, so 5 plus 5 will end up to give us 10. Then we need to add that to square root of 50. So we go plus square root of 50 is going to end up giving us a grand total of about, we're going to use the approximate symbol, about 17, make sure I put my 1 first, 17.07. That is our perimeter. Notice we have less string that we're using, or less tape, whatever we're using to dictate the shape. So far we look like we want to go with A, but let's find the area, because we want to find both the area and perimeter. Area of the triangle, remember it's base times height divided by 2, or half base times height. So this would end up to be just 5 times 5 divided by 2. 5 times 5 is 25. Divide that by 2, and that is going to give us a grand total of 12.5. So that is our area. Notice we want to go with the circle. So if Mr. Stowell wanted to do this for a programming class, we would want to do the circle with radius 3, because that gives him the biggest circumference or perimeter, and it uses the most tape, and it also uses the most area. Last one. Find the perimeter and area of the polynomial. We use a symbol here to indicate a polynomial, okay? And we make sure that it's written in order of points A, B, C, D. Basically, we're just going to go around the circle, or around the shape. So if we have point A being negative 3, 7, this is going to be right here. This is point A. If we have point B being 1, 4, that's right there. If we have point C being 2, 0, and point D being negative 6, 3, we would end up with our shape looking like this. Make sure that we get straight lines, connect our vertices, and that's our shape. Well, the issue is, what is the distance from A to B? What is the distance from B to C? What is the distance from C to D? Make sure you write out D. Well, we're going to use our distance formula. Distance formula is going to come up over and over and over again. We need to remember our distance formula. So what we're going to do is we are going to extend these sides and make some right triangles. From the negative 2 to this edge here, that's a distance of 3. From down here to that vertice is a distance of 4. Let's find the distance from B to C. So B to C, that's our hypotenuse. So this would end up being 3 squared plus 4 squared, which gives us 9 plus 16, which is going to be 25. Of course, this is this quantity squared. So if we want BC, the length of BC, then we had to take the square root. So this would end up being distance of 5. So B to C is 5, because that's a 3, 4, 5 triangle. From here, B to A, we go up 1, 2, 3. We go over 1, 2, 3, 4. That's nice. That's also distance of 5 from A to B. So that's congruent. From A to D, we have 1, 2, 3 that we're going over. We're going down 1, 2, 3, 4. Also 3, 4, 5 triangle. So that's also congruent. Lastly, we're going down 1, 2, 3. Going over 1, 2, 3, 4. Also 5. That's nice that we have a square. All side lengths are congruent. All angles are congruent, by the way. So with this one, we have all side lengths, which are 5. Now let's go ahead and just find our perimeter. Perimeter equals to 4 times 5, because we have 4 side lengths, so this would be 20. Area is going to end up to be 5 times 5, or 5 squared, which is 25. So that's our area, that's the perimeter of this shape. Main idea, look for the distance formula whenever you're graphing. Whenever you're using the coordinate system, you're going to have to know your distance formula, which we talked about in a different video.